All right. So we are looking at the derivation of between Kp and Kc. So in analytical chemistry, physical chemistry, you look at this. Even in biology, yeah, you talk about this. Okay. So in general, we are deriving Kp and Kc. Okay. The relationship. We want to look at the relationship now. All right. Okay. So so given a reaction at equilibrium, so we'll give a reaction at equilibrium. Suppose we have now a reaction at equilibrium. So suppose we have A reacting with B, so giving us a equilibrium reaction to give C product plus D product. So what we do then, there are always the coefficient that balance the reaction. So we put A there, we put B there, we put C there, we put in front here, we put D there as well. Okay. So given this, how do we find now the equilibrium constant? So the equilibrium constant will be the ratio of product over reactants. So we'll say Kc in terms of these are to be concentrations. So we are looking at the concentration of all these reactant and products. So we'll say it is given as concentration equilibrium is given as the concentration of C, okay, raised to the power C, then times the concentration of D raised to power D, okay, over, all right, we have again the concentration of A raised to the power A. Again, we have the concentration of B raised to the power B, like this. Okay, so this is the Kc now, the concentration. All right, this is the Kc value. That's how we obtain the Kc value, like this. Okay, similarly, if we have Kp, then in terms of partial pressure, or in terms of just pressure, so we'll have partial pressure of C. Okay, so partial is not constant like that. We put the brackets like this. So raised to the power C. Okay. Again, we have partial pressure of D raised to the power D. Okay. Over. We have again partial pressure of A raised to the power A. Again, we have partial pressure of B raised to the power B. Be like that. So that is it. Now, from ideal gas equation, we know that from ideal gas equation, from ideal gas equation, all right, from ideal gas equation, we know that we know that PV, okay, is equal to nRT. All right. So dividing throughout by V, so say pressure is equal to more over volume is the concentration, molarity, concentration in moles per decimeter cubed or moles per liter. So that is the concentration, okay? Then RT, like that, okay? So this means that wherever we have P in this Kp, all right, we'll be putting this, okay? We'll be putting this. This should be the concentration placed in those brackets. Those brackets actually means concentration. Just the normal brackets, they don't mean concentration. They mean something else. All right. So, so that is it. So this means that, so this means that, uh, this means that, this means that we have now P. So we'll get this Kp, all right? So we'll get this Kp now. We'll say Kp, all right? My handwriting is very bad. Okay. So we'll get this Kp. So, and say we'll be putting now, we'll be substituting all of these now. These are kp's. So the p now, wherever there's this, we'll be putting this. So we'll say the concentration of p, all right. Okay, so I'll be putting this, I'll be substituting that. Okay, so for a, so these are the concentration, and where I'll be putting these letters appropriately. So for the first one, we had this A. So wherever there's A, I will substitute that. Okay. So we have C. Okay. C concentration like that. Then R T. Okay. Raised to the power as shown there. Okay. The power C. Then again, we open bracket. We have D. Okay. Again, R T raised to the power D. All right. So we have again we have the same one again for A now. Concentration of A, then R T, then to the power A. Okay. Then we have again open bracket concentration of B. All right. R T of B. So let's the power B like that. Okay. So now this is the expression. So I'm going to distribute these powers now inside. We know we rent this. We know this. So I'll distribute that. So I'll say Kp, all right. So I'll say Kp, all right, is equal to this C concentration, okay. So this C now will be distributed inside there. So we have C there, and also we have Rt, okay, just in these brackets because that's where they had no brackets like for concentration. Then we'll put again C there. Then times again will come concentration of D. All right. Concentration of D raised to the power D distributed as follow. Then we have again RT of D raised to the power D like that. Okay. So over the same happens. So we have concentration of A, okay, raised to the power A, then RT, okay, raised to the power A. Again, we have B concentration raised to the power B, okay. Then we have RT, then raised to the power B, because that's where they came from. Then from there, we can now combine these and these, they have the same. So we add the powers, okay. So I'll group the like terms like this. Kp is equals to this C will remain as concentration of C raised to the power C, okay. Then we have now again concentration of D, okay, raised to the power D. Then for R, for this one, RT and RT, will add the powers just. So write RT, then we have C plus D, because they were two, they had the same bases. So I've just added the powers, so there's nothing to stress. We don't have to stress much there. So even this, I'll do it on the on the reactant side, the down part. Okay. So we have also concentration of A raised to the power A, then concentration of B raised to the power B, then we have RT, okay. Then we add, now we have A plus B. These they're adding because they are same base, which is RT. So they have added like that. So you can see it is only this now which will get a negative. Again, they have the same. So indices of dividing, we subtract. Okay. Indices of dividing, we subtract. So that means Kp, okay, is equal to without even wasting our time there, have you seen now this boundary? So we have this boundary now, okay. So this, if you look at the way we found Kc, this is giving us Kc. We know that that part is equals to Kc, so I'll put Kc there, okay. Then so Kc, then we can see now there's change in moles. So write RT, okay. We have C plus D, okay, minus open bracket, there's A plus B. So this is just a change in moles, all right? This is a change in moles. So this is the change in moles. So we can substitute that to say Kp, okay? Finally, Kp, okay, is equal to um, Kc, okay, then Rt, okay, then change in moles. That's just change in moles, hence derived, okay? So that's how you can derive actually Kc. This is the relationship that you'll be using in your studies. So remember, it was so sweet. We did that. This part was representing Kc, of which we calculated in the previous page. Kc, this concentration, we could see that this is the Kc expression. We could express them in this form. So that's how we have found that. Otherwise, try to follow this. Try to follow all the steps, then you'll be able and delayed to go about mastering this. They are very simple. Okay. So that is it. That's physical chemistry, analytical chemistry. All those can cut. Thank you very much. Thank you very much.